Hayalperestlerin, risk alanların, denemekten korkmayanların cesaretinden doğduk. Bizi asla yarı yolda bırakmayan o sesin rehberliğiyle ilerlemeye ve öğrenmeye devam ediyoruz. Bunun için varız. Bu yüzden gece geç saatlere kadar lambalarımız sönmez. Elveda demek hem hüzün hem de gurur verir. Her şeyi sorgulayarak ve merakımızı besleyerek, dayanıklılığımızı test ederek, sınırlarımızı aşarak, ilerleyerek ve yeni ufuklar açarak yeni bir yol buluruz. Yeni icatlar çıkararak, kendi yolumuzu çizerek. Burası fikirlerin doğduğu ve yeni fikirleri doğurduğu, bizim de doğduğumuz, birlikte büyüdüğümüz ve yükseldiğimiz yer. Burası Yakın Doğu Üniversitesi.
Hello everyone, and welcome to our first session in room 1. I would like to thank everyone for attendance. And we would like to start with our first presenter. Professor will be Professor Igor Ludovic. He's going to be presenting the paper titled Introduction to Marine Education Remote Sensing and Monitoring of Oil Spills in Maritime Areas. Professor Igor, welcome to our conference.
Welcome. I'm trying to get the
Share your screen. To share your screen,
to share screen. Yes.
yes, just click on present, share screen.
Yes.
Then from share screen, you can select Windows in the middle. Then from the Windows, you open Windows. Yes.
Let's see.
That's okay. Just press on your PowerPoints. Okay.
Share screen. Share.
From share screen, select Windows in the middle. From this Windows,
Yes.
select your PowerPoint.
Okay.
Yes, and please put it in the reading mode so we can see full screen.
Yes. Do you see slide?
Yes, we
PowerPoint.
can see it, but if you can put it in reading mode so we can see a full screen for your slides.
So let's do this and then.
No, not view mode, because if you put it in view mode, you will not be able to see it in full screen. Just reading mode, the one next, right to the left of view mode. The open book icon.
What's this? Is it okay now?
Just 1 second, it's loading. Yes, perfect.
Yes, now it's okay.
Perfect.
Okay. Thank you for. I'm writing this, and I'm calling you from Croatia. It's nice to expand our knowledge during your conference, and we hope we'll have some also that you will have some use of us also, right? So I want to show in today's presentation our experience in introduction of new technologies in maritime education. It's a very interesting topic because nowadays even education is actually, unfortunately, industry, and we provide seafarers for the companies. Satellite imagery is very interesting because it's a modern thing to nowadays, since satellite imagery for surveillance applications are now increasing due to new modern technologies such as artificial neural networks, artificial intelligence, etc. There are many reported attempts to monitor the spread of oil spills using remote sensing. Introducing remote sensing into the classroom will help to create awareness of the opportunities that this technique offers for sustainable development and ecology, green economy. Remote sensing also enables the monitoring of ships discharging oil or fuel and various forms of pollution. And there is a need to investigate whether multispectral imagery can be used to detect illegal discharges of ballast waters, etc. So there is a lot of potential research. Remote sensing also can be used in creating traffic portfolio, uh, counting ships, and etc. The scope is possibility of remote sensing in maritime transportation, but how to include it in education. And our motivation for doing this is actually here because we want to introduce remote sensing into the classroom. So this is the beginning of the scope. So you can see here there are possible applications of remote sensing in maritime. There are underwater and surface applications from industry, industrial fishing, track reconstruction, ecology, habitat use, ocean productivity monitoring, etc. At the surface, we have environmental variables such as wind, weather conditions, currents, and similar, which could be of interest. So based on the sensor type, there are various applications. For example, if a sensor platform uses optical spectra, optical spectra can be used for monitoring fishing fleets, barometric mapping, monitoring phytoplankton, hurricanes, meteorological conditions, and similar. Motivation for entering this technology into education is that this is a relatively new technology, new in the sense that it's not completely included in standards of training, certification, and watchkeeping provided by International Maritime Organization. Hence, this new technology should be integrated into education curriculum to cope with advances in technology. Making educational process more interesting is one of motivations for including this subject into education to the class. Then we have better teaching technique because it's teaching by doing. Hence, students should something actually do or simulation of doing something, and they can learn more than simply listening to the lectures. And finally, this could lead to informing the students of new trends that could be expected in the near future in their careers. Ways to introduce remote sensing in education are several. First of all, someone can start with students' thesis and graduate thesis. That is the usual approach, something like pilot project in economy, in businesses. Then we can change the curriculum of existing courses by integrating some new technologies and then implementing new knowledge through new courses. In this presentation, we focus on this last. This is the toughest thing because it needs changes that must be approved by educational agencies and by university. Hence, we decided to apply to the European Space Agency project. The title of project, which will incorporate including of new course of remote sensing into maritime education, was called it's called actually remote sensing and function of sustainable development of maritime sector. Contractor name is our institution, University of Split, Faculty of Maritime Studies, and subcontractor is from business, is List Labs. This is a small company from Zagreb. Like any other project, we had to comply with several things, such as defining project goals, assess the risks, allocate required resources, strategies that plan and execution process, maintain healthy communication, etc. There is always challenges in this process. Even European Space Agency asks us about risks. So what could be risks in education? So we find, for example, that risk could be that no one enrolled this course, this new course. So there is no actual control, is it good or not? And we need some considerable number of students to check is it good or not our approach in introduction of new course. So curriculum starts with lessons, introduction to remote sensing. Introduction to remote sensing means that we deal with overview of remote sensing principles and concepts. We have in-depth understanding of electromagnetic spectrum sensors, types of remote sensing platforms and characteristics, historical development and significance to maritime sector. Then we have lessons about satellite constellations with the focus of SANTEL missions, which means that we have exploration of SANTEL's missions, their role in Earth observation and maritime applications, and in-depth look at satellite constellations beyond SANTEL. Finally, we must tell students how to understand the difference between different sensor platforms and sensors because they are not all from the same background. And that is also the challenge. Then we have a lesson about data acquisition, processing, and analysis, which includes importance of data acquisition strategy in maritime remote sensing, theory of data preprocessing, including basics of atmospheric corrections, theoretical foundation of image enhancement and classification. Next lesson was about oceanographic application and remote sensing application oceanography. That's a theoretical underpinning of remote sensing applications in oceanography, understanding the principles of monitoring sea surface properties. Next lesson was about software tools for remote sensing and spatial analysis. This means introduction to QGIS. This is an open source geographical information system. Then overview of importance of visualizing spatial data. Theoretical foundations of software tools for remote sensing, data manipulation and visualization using software tools in a remote sensing context, and something about other popular software packages, not just for this geographical information systems, since there are other packages can be used for this purpose. Next lesson was about applications of remote sensing and geographical process. It's about theoretical knowledge related to fuel consumption and greenhouse gas emissions, reactive gases from ships, traffic that can be calculated based on fuel consumption, installed power on the ship by analyzing the overall picture of the ship's layout and the numbers of arrivals and departures for individual vessels that are estimated by performing calculations from below upwards. Actually, this is based on actual features and ship tracking. Then we have the use of available geographical data from European Space Agency database on CO2, methane emissions, and nitrogen oxide emissions. There are monthly, yearly that can be inverse modeling. And finally, students should make a proposal for exercise for vessels with the purpose of reducing the emission of harmful gases. The next lesson was case studies in sustainable maritime development in future tense, including artificial intelligence. This means analyzing real-world case studies, evaluating the impact of remote sensing in sustainable maritime projects, discuss the discuss upcoming technologies and trends, theoretical exploration of artificial intelligence and machine learning in maritime sustainability. Then we have lessons about environmental monitoring and compliance, which includes theoretical framework for environmental monitoring using remote sensing and the role of remote sensing in maritime compliance and regulatory standards. The other part, of course, was exercises. This includes the setting up GIS, graphical information environment, and introduction to basics. And students set up the software, become familiar with functions. Then they learn how to acquire and pre-process Sentinel-1, Sentinel-2 satellite data. Students learn how to access and download this data for Copernicus Open Access Hub. They import this data to their software. Also practice data pre-processing techniques, which is also important to see in case example later, the importance of pre-processing to enhance the image. Analyzing sea surface and energy properties trends from satellite data is the next exercise when students analyze trends in sea surface properties using data from Sentinel, then try to identify anomalies and changes over time, and then real-world use cases which are presented by our co-partner from business. Then analyzing atmospheric compositions and air quality as an example of applications, which includes analysis of impact to maritime traffic, to quality of air, etc. Then we have lessons about combining Sentinel-1, 2 data from multispectral analysis. When students learn about multispectral analysis, how to fuse or to extract some of data. And real-world case, our partner from business proposed plastic Iceland's detection as an example. Last but not least, lessons in exercises about identifying environmental risks using remote sensing data from maritime disaster management, and classification of satellite imagery when students learn how to collect, training, and test data and perform simple binary and multi-classification of that data. Hence, the last slide about this curriculum of exercise is creating basic scripts for data manipulation. Then group projects where students apply what they are learned to real-world maritime challenges, and presenting, discussing, and evaluating the results of practical exercises. As you are all aware, oil spills detections can be performed by different platforms. If you use satellites as platforms, sensors can be LIDAR, radar, infrared, optical, and similar platforms. They can be microwave, including electromagnetic radiation, such as K-band, which is in NATO or EU classification as the X bands. So this is an example. Here is a case study of oil spill at sea. It's actually on coasts. When students can learn how to input the original image. This is This is here original image. And then can they transfer this color image during the different functions to enhance this image. This is particular.
Prof, sorry very much for the interruption, but time is up. If you can please.
Yes, I'm almost finished. Don't worry, I take care. So this is enhanced images, and this is performed by Wavelength Transform in MATLAB. The problem was that most students didn't have a DSP course and don't know Wavelength Transform. This is examples of analysis with Wavelength Transform of original enhanced source images. And histograms can be used, for example, in spectral analysis to find or enhance oil spills. Finally, I can conclude that ESA insisted on more exercises. Our original proposals was 2 hours of lectures and 1 hour exercises per week, and they insisted on opposite 1 hour of lectures and 2 hour exercises. And as I didn't like MATLAB, which is usually an academy, yeah, so we have to choose open source geographic information system. They alternatively propose Untitled toolbox. And finally, there is also a problem with different origin of our students. There are some from management, from logistics, for marine engineering, and also from marine electrical engineering and IT technologies, which are more familiar with programming environments. So we have to adapt to everyone this course. So thank you. I sorry if I took a little bit more time. I prepared more. So thank you for your attention.
Thank you.
Do you have questions? Right.
Thank you very much, sir, and sorry again for the interruption. Thank you very much for the presentation. Anyone has any question? Seems like no one has any question. Thank you very much, sir. Thank you very much, Prof. With the perfect presentation. It was our pleasure. Now I would like to move to our next presenter, Dr. Budrigala, going to be present the paper titled Water Resources Management of Mitigating Soil Salinization Causes of Drainage Affairs. Doctor, please, there is some noise in the background. Thank you.
Thank you. Okay. Hi, I'm Dr. Banu Priya. Okay, I'm just going to present my topic. 1 minute.
Doctor, we cannot see your PowerPoint here.
Is it?
Just click present. Then yes. Thank you.
Is it seen?
Yes, it's.
Yeah.
Thank you very much.
Thank you. Okay. Now my topic is about geographic information system data of groundwater and its impact on human health in Dindigul district of Tamil Nadu, India. Okay. So see, this district is in Asia actually. Southernmost part of in Asia, it is in India. Okay, one of the prestigious country in the world, and in India we are staying in southernmost district, and it is Tamil Nadu, and our sample site is on Dindigul district. So I'll just give you an introduction about the groundwater. So groundwater is the major source of water supply for us. Okay, mainly for drinking purpose. It may be directly or indirectly affects the urban development, and we use it for industrial purpose, agricultural activities in almost all part of the countries. The groundwater resource plays a very significant role in meeting the agriculture and domestic sectors. So if the quality of the groundwater is affected or contaminated, the entire country will be collapsed without the water, because we have seen both without water how the state will strive, and with water, how much difficulty we face. Both the things we have been seeing very constantly during the monsoon seasons. So, out of which, what are the diseases caused by? So, in our sample site, I have taken Dindigul district. In our sample site, dengue is a major disease which is caused by Aedes aegypti mosquitoes and Aedes albopicus mosquitoes, so which is responsible for causing dengue. So it is in recent years it is a major international public health concern. So found mainly in tropical and subtropical regions of the world. Now, medical GIS has done here to pivotal role to locate, monitor, and identify the disease. And the statistical analysis using SPSS, that score analysis was performed for the selected environmental variables with the disease incident rate to locate, monitor, and identify the disease. So study area. So I told you, right, India is a prestigious country, and we in India we are living in a southernmost state, that is Tamil Nadu. In that we have taken one district that is named as Dindigul district, which lies between Tiruchirappalli and Madurai. So the total geographical area of the district is around 6,036.11 kilometer. So this is the location of the study area. See, this is our India map. Sorry, 1 minute. This is our India map, and in India we are located in Tamil Nadu. In Tamil Nadu, see in this blue color regions there, that region is Dindigul district, which has been emphasized here. Okay, for the study, the materials and methods. So we have taken the groundwater data from Taramani Central Groundwater Board, Chennai. The collected data was divided into post-monsoon and pre-monsoon seasons. The post-monsoon season was taken during the month of January, and pre-monsoon season was taken during the month of July. And here we have taken mostly wells. Why we have taken wells is wells are the predominant source of water in India, especially in Tamil Nadu. We are every households, if you take nearly every places in the Dindigul district will have at least one well. So out of which some wells may be very good in condition, some wells may be in dry condition, some wells without water it may be it would have been closed. So in common we have taken 17 common wells for all the years for both the seasons are extracted based on BIS standards. BIS is nothing but Bureau of Indian Standards, which we follow throughout our India. So location of each well has pointed, and the result of each chemical parameter of water has been joined to the point as an attribute. And final database was created using ArcGIS software. And the spatial analysis tool have been identified using inverse distance weight method for generating the surface area. And multiple types of clusters were used to identify the physiochemical parameters of the groundwater. Next, domestic water quality index and irrigation water quality index has been performed by following Tiwari and Mishra's method. And dengue strain was an important technique in statistical analysis and cartographic interpretation. This was spotted out by using GIS software of an ArcView. So the disease maps were determined, and Z-score analysis was performed for correlation and interrelationship between the disease and the environmental factors. So results. So according to Bureau of Indian Standards, we calculated the waters with the different chemical parameters such as pH, TDS, total dissolved solids, sulfates, chloride, sodium, potassium, calcium, magnesium, and fluoride. This is the standard value which is followed in throughout India. So the weightage of all these together was around 27, and the relative weight summation will be around 1. So next will be the TDS. In TDS, if you take total dissolved salts, the minimum and maximum value of the domestic groundwater quality parameter was estimated. In this, major cations and anions with the different groups was being categorized. In post-monsoon season and pre-monsoon season, we have chloride ions as most abundant compared to the other chemicals present in the characteristic features. So in this chloride ions, the mean value was found to be higher as 202.84, and in pre-monsoon it is about 197.49. So the overall interpretation was domestic groundwater quality parameter have more amount of chloride ions compared to other chemicals parameters. The classification of chemical parameters for based on BIS standard. See whether since we are analyzing with the groundwater, we have to know what is the permissible level and what is not permissible, what is desirable level for the sustainability class for taking up that groundwater. In that groundwater, we found that since we have analyzed the 17 wells, almost 16 wells were desirable and permissible for sulfate, which is having high concentration, high percentage of chemicals present in it. See, this is the BA standard values that pH should be around 8.5, whereas for us it is around less than 8.5 or greater than 8.5 is considered as permissible. Whereas less than 8.5, here we have 1. So, like post-monsoon and pre-monsoon, comparative data has been analyzed, and sulfate was found to be higher, and desirable and permissible levels both were considered to be higher in both in almost all 17 wells. And water quality index of pre-monsoon and post-monsoon season. See, if you are taking a water, that water is almost we constantly intake water, right, for our healthy hygiene and healthy body activities. So to determine that, water quality index plays a vital role in maintaining good health. So this was characterized for both pre-monsoon and post-monsoon season, out of which 2 wells in both pre and post-monsoon were found to be excellent source, which is less, where water quality index was less than 25. Whereas if the water quality index was more than 100, it is found to be unfit for drinking. Almost 3 wells in the Dindigul district with 11.64% were found to be unfit for drinking. Next, this is the spatial distribution of water quality index. See, in this index, you could see that red color spots, which is unfit for drinking purpose. Whereas this blue color dots are there here and there, right? Very dark blue dots. That is less than 25, and it is excellent source of water where people can consume it. And 25 to 50, and is also surrounded by that light blue. That is also good source of water. So next is irrigation groundwater quality. So apart from drinking and health and hygiene purpose, irrigation is agriculture is the major source in Tamil Nadu. In agriculture, we supply water, right? So for that irrigation purpose, the water quality parameter should be maintained. So for that purpose, we have sodium absorption rate, electrical conductivity, followed by that is RSE, that is nothing but a residual sodium carbonate, percentage of sodium has been analyzed, permeability index, magnesium ratio, Kelly's ratio, and soluble sodium percentage was being analyzed. In this post and pre-monsoon seasons, we are just classifying that what is the minimum concentration of each irrigation parameters, and in both pre-monsoon and post-monsoon season. Among that, sustainability classes should be excellent, that is less than 10, and it is say whereas RSE, if you consider, it should be less safe enough so that residual volume should be safe enough so that it should be less than 1.25. So based on this criteria, we can conclude that the percentage of post-monsoon and pre-monsoon has been found with the irrigation parameters. Next, salinity hazards. Salinity is nothing but the salt content present, and what are the hazards it's caused in this sodium absorption rate, electrical conductivity, and those parameters. So excellent. So now one sample is in irrigation purpose, one sample is considered to be excellent, and 5 samples are considered to be good. Whereas 10 samples are in doubtful case, and one is totally unfit for drinking or unfit for any irrigation or any other purposes. Okay, and the same thing happens here in post-monsoon season, in which now one sample is found to be excellent, and 4 samples were considered to be good, and 10 samples are doubtful, and 2 samples are totally unsuitable for irrigation purpose. Next is this sodium alkali hazard, in which the hazard level at C3 has been, C3 is considered to be very high. C1, C2, C3 and C4. C1 was very low, and C2 is medium, C3 is high, and C4 is very high. See, in these two tabulations, we could see that in C3, the chemical contents, we have seen different chemicals now, right? Sodium absorption rate, residual volumes, all this were found to be very high in pre-monsoons, that is around C3, that is which is found to be high in this chemical parameters. The spatial distribution of the sodium absorption rate and electrical conductivity for pre and post monsoon season were being demonstrated in this graphical representation. And this light yellow is there, right? That is considered to be the excellent source of sodium absorption ratio. And electrical conductivity here, see the light yellow dots are there, right, in the corner. Those are considered to be excellent source.
Doctor, sorry for the interruption, but time is up. If you can please.
Yeah, I'll just finish. Yeah, 2
Thank
minutes.
you.
I'll just finish.
Thank you.
And this is the residual volume of the map, which I have already told you in the tabulation, and sodium percentage graph. And here see that light violet color represent suitability of magnesium. And Kelly's rally is also found that 1% is suitable with this light pink in color. And the irrigation zones identifying the water quality parameter index was being represented here. And next, finally, it is the dengue case report, which has been demonstrated that in Dindigul district, the Z-score value is around 0.19, and 0.30 male has been analyzed as being more infective, and female was 0.77. And this is the spatial temporal variation of the dengue cases in Dindigul districts. The Z-score value is very high in northeastern part of Veda Sandur and south and southern east part of Nelakotai, and lower in Ottanchatiram. And it was very much high in Dindigul district and Natham in the test which we conducted. And the spatial distribution of both male and female has been demonstrated here. And the spatial distribution of dengue cases, where depending upon the age group, it has been considered. So from 0 to 14, 14 to 35, and 35 to 60, and above the age of 60. How much percentage was being affected? So summary, the present study has investigated the suitability of groundwater for drinking and irrigation, and general characteristics like major cations and anions in the groundwater derive the water quality indices, and it has been calculated for both post and pre-monsoon season. And DWQI reveals that 53 and 59% of groundwater samples are poor water quality, and about 12% of samples are unfit for drinking. Assessing the integrated water quality index reveals only 3% in post-monsoon and 6% in pre-monsoon season. So conclusion, it helps us to study the quality of water for drinking and irrigation, as well as to develop suitable management practices to protect groundwater resource where it is affected. The spatial distribution of dengue was observed in the lower and central part of the districts. And the prevalence rate was very high in north, south, and western part of the district, and because of the unprotected water supply. And sex-wise prevalence rate of dengue disease was showed that male population was worst affected than the female population. So thank you. Any questions you can share?
Thank you very much, Doctor. Any questions? Okay, seems like no questions. Thank you very much, Doctor. I'm sorry for the interruption.
No problem. Thank you very much for the opportunity also. Thank you.
Thank you very much, Doctor. Now I'd like to invite our next presenter, Mr. Feliz. We're going to be presenting the paper titled Assessment of Land Use Cover Changes in Central Anatolia region in Turkey using NDVI. Mr. Feliz. Mr. Gürkan, pardon, Mr. Gürkan.
Hello everyone. First of all, I would like to express my gratitude to the Rectorate of Near East University for providing us with such an opportunity to present our research. I am Gürkan Özgoncu. I am a student in the Environmental Engineering Department at Erciyes University. The topic of the paper I will be presenting is assessment of land use cover changes in the central Anatolia region using NDVI. The primary objective of my study is to identify land use cover changes in the central Anatolia region of Turkey based on the analysis of satellite imagery. The normalized difference vegetation index was calculated for land use cover classification. My study area is Central Anatolia region, which covers 13 provinces and covers 21% of Turkey, with an area of approximately 151,000 square kilometers. Urban, agricultural, and uh, industrial areas make up a significant part of the study area. It also includes a number of lakes and wetlands, such as Tuz Lake. Remote sensing is a tool that allows us to obtain information about the land surface without physical contact. Images obtained at certain time intervals through satellites can be analyzed in a computer environment to reveal information about land use cover. The normalized difference vegetation index, the main term of our research, is calculated using information from the red and near infrared bands and is one of the most widely used indices. NVI helps to measure the greenness of the land surface and is sensitive to vegetation density and plant health. NVI ranges from -1 to +1, with values approaching +1 indicating higher vegetation density and values decreasing towards -1 indicating lower vegetation density. The Landsat imagery used in the analysis was obtained from the United States Geological Survey. Images from 1987 were selected from the Landsat 5 Team Mapper archive that collected that data that year. Since 2022 is a close year, Landsat 8 OLE images were used. We carefully scanned the Landsat archive and aimed to obtain noise-free and cloud-free images. We also aim to obtain images from the same time of year, as our ultimate goal was to detect changes between different years. We collected 23 satellite images for each of the years I selected. We mosaicked these satellite images throughout the ArcMap program. NDVI is calculated as the ratio of the difference between the near infrared bands and the red band to their sum. We perform these operations in the computer environment with the raster calculator process. Calculated NVI values, of course, have a correspondence. Wetlands when the NVI value is less than 0, 0.2, 0.2, 0.2 2% bare soil. Between 0.2 and 0.5 means sparsely vegetation, and in areas greater than 0.5 means a high vegetation density. When 1987 and 2022 are compared in terms of land use scope with wetlands, which covered 10.58% of the total area in 1987, decreased to 1.18% in 2022. Wetlands are decreasing. Another class that decreased between these years is bare soil. Sparse vegetation and dense vegetation classes increased spatially. When compared in terms of maximum NDVI value, the NDVI value, which was 0.198 in 1987, was calculated as 0.69 in 2022. As I mentioned in my presentation, this study has shown that significant land use cover changes have occurred in central Anatolia. In the future, we will investigate the possible causes of the changes. Thank you for listening to me.
Thank you very much, Mr.
Thank
Gürkan. Any questions from Mr. Gürkan? Okay, seems like no questions.
Thank you.
So I'd like to invite our next speaker. Will be Dr. Sumuya. We have a recorded video. We'll play now. Mr. Abdullah, if you can please play the video of Dr. Sumuya. The paper titled AI and Climate Change, Theories, Tools, Benefits, and Disbenefits.
Hello, distinguished scientists. My name is Dr. Abidemi Shomoye, and today I will be presenting in the 6th International Conference on Natural Resources and Sustainable Environmental Management. Our topic is Artificial Intelligence and Climate Change, Theories, Tools, Benefits, and Disbenefits. And my co-author is Toluwalope Akinwande. Climate change, defined as changes in average weather patterns, is one of the topics being discussed at the global level. The discussions involve climate experts, economists, healthcare professionals, national governments, business leaders, non-governmental organizations, international organizations, amongst others. The causes of climate change include natural and human causes. Let's take a look at some of the natural causes. Natural causes such as volcanic eruptions, solar radiation fluctuation, tectonic shifts, and small changes in orbit. On the other hand, it has been established that human causes are driven by emitting greenhouse gases such as CO2, nitrous oxide, methane emissions, water vapor. Out of the greenhouse gases, it is important to state that CO2 has the most environmentally damaging effect. Now, why are we talking about climate change, or why are the discussions centered around climate change? Now, one of the reasons is because of the effect of climate change, which includes increasing temperatures, severe storms, increasing drought, rising sea levels, loss of species, inadequate food, health risk, poverty, and displacement, among others. So due to this damaging effect, mitigating, adapting, and resilient solutions are being designed. And one of the recommended solutions is the use of artificial intelligence. All right. Another recommended solution, which is outside the purview of this study, is the adoption and the utilization and the development and use of renewable energy sources. But the use of AI can be used to benefit the renewable energy adoption and utilization. Now, let's take a very brief look on the definition of artificial intelligence. According to Sembeck and Mutlu, artificial intelligence can be defined as machine intelligence or computational intelligence. Now, Russell and Novick summarize the definition of AI as systems that think, systems that act like humans, a system that thinks rationally, and a system that acts rationally. In addition, early development of artificial intelligence or AI can be traced back to McCulloch and Pitt, 1943. They drew upon three different areas to develop their model. Neuroscience, which has to do with the brain, logic, which has to do with thinking, and computer science or computational science. Now, let's look at some of the different disciplines that contributed to the growth of AI. They include philosophy, mathematics, economics, neuroscience, psychology, computer and engineering, control theory, and cybernetics and linguistics. In addition, aside climate change, aside using AI to solve climate change problems, AI is also beneficial to the health sector, to cybersecurity, cultural and financial benefits for businesses, organizations, marketing. It can be used to reduce inequality. It can be used in the legal system and law enforcement, international trade, education, and also artificial intelligence or the adoption of AI can drive economic growth. And you can see the authors who have backed up this assertion. Now, Gibbons 2021 also opined that the unchecked growth of AI could lead to concentration of wealth, power, and decision-making authority in the hands of a small number of powerful actors, further widening the gap between the rich and the poor. This study contributes to the existing literature by reviewing the studies on AI and climate change nexus. The literature on the relationship between these variables is still growing, which requires more studies for sound and robust policies. In addition, this study discusses the tools, theories, benefits, and disbenefits of adopting AI to solve climate change problems. Now, let's look at some of the theories that relate AI and climate change. And one of those theories is what we call environmental Kuznets curve. Although the environmental Kuznets curve does not directly talk about technological innovation and climate change, it talks about economic growth and environmental degradation. And this relationship between economic growth and environmental degradation comes in three stages. And those stages are scale effect, structure effect, and technological effect. So the technological effect, that's where it comes in. So at the initial stages of economic growth in a country, we are going to foster economic activities, all right? And structural effect will be at a situation whereby emissions get to peak, okay? Because the economy is growing. And also structural effect simply means when a country begins to move from an industrial base to a service-oriented economy. And lastly, the technological effect will be the use of technology in the production of goods and services. Or it says here that subsequently, technological advancement, particularly the adoption of clean technology, would contribute further to reducing pollution levels. And this is because when you use new technologies in production of goods and services, there will be a decrease or there will be a decline in CO2 emissions level, which is a form of greenhouse gases as we have discussed. The validity of this hypothesis has been established in most advanced economies because you know that these advanced economies that are using more of renewables. Okay. Now, let's look at another theory, which is the Porter's hypothesis. The Porter's hypothesis is linked to environmental regulations, which stimulate innovation and reduce ecological protection costs. The association between these two variables can be categorized into two main viewpoints: the compliance cost and the innovation offset effect. Okay, so the compliance cost is trying to say that the cost at which the firms or businesses have to bear by adhering to environmental regulations. Okay, that is the compliance cost. On the other hand, the innovation offset effects talked about that the innovation offset effect suggests that environmental regulations can trigger a positive feedback loop where investment in environmental protection lead to technological breakthroughs that enhance economic efficiency. Furthermore, Jeffrey and Palmer differentiated between weak and strong Porter hypothesis. Weak Porter hypothesis is innovation-driven, while strong Porter hypothesis is a combination of innovation and the promotion of efficiency gains. Now, let us look at some of the AI tools used in climate change research. We have machine learning. Machine learning is a subfield of artificial intelligence, which is broadly defined as the capability of a machine to imitate intelligent human behavior. Artificial intelligence systems are used to perform complex tasks in a way that is similar to how humans solve problems. Machine learning can be subdivided into supervised learning, unsupervised learning, and reinforcement. So let's take a brief look at supervised machine learning. Okay, supervised machine learning models learn and enhance their accuracy through the utilization of labeled data sets. Unsupervised machine learning delves into the depths of unlabeled data, uncovering hidden patterns and relationships that would otherwise go unnoticed. And reinforcement machine learning trains machines to take optimal actions through a trial and error process, which where rewards guide their learning. That's according to Brown 2021. So let's also take a look at deep learning. Although deep learning is a subset of machine learning. Deep learning is a subset of machine learning, and it utilizes artificial neural networks with multiple layers to learn from data. Unlike traditional machine learning algorithms, we typically employ shallow neural networks with a single few layers. Deep learning algorithms incorporate deep architectures with multiple layers of interconnected artificial neurons. Okay? In addition, deep learning entails employing analytics and machine learning to identify the best suitable approaches for achieving a higher degree of accuracy. Right. Deep learning, according to Boredom et al. 2011, contains 4 phases, including content, interpretation, development, and integration. Now, let's take a look at AI benefits and disbenefits. All right. It has been established that AI can be used to predict weather conditions effectively, especially through the artificial neural networks, like when we're talking about deep learning. Okay, so that's one thing. AI can be used to predict weather variables or weather conditions effectively. Another thing is the AI can facilitate and foster environmental governance. Okay, can facilitate and foster environmental governance. According to Nishant et al. 2020, one of the disbenefits is that AI, the use of AI, one of the problems is that over-reliance on historical data for machine learning models. The unpredictable nature of how people might react to AI-powered initiatives and a rise in cybersecurity risk. So these are some of the disbenefits, or these are some of the bottlenecks or challenges encountered. Okay, according to Lucioni et al. 2021, AI can be used in climate change impact visualization, such as floods, storms, and wildfires. So it means that if we know that there are going to be floods or storms or wildfires, then we could quickly have mitigating solutions, okay, mitigated oriented solutions to be able to prevent these climate crises. Bamdal et al. 2021 also says AI can control the production of energy, thus reducing CO2 emissions. All right, that can also mean that efficient use of energy, because the efficient use of energy drives down CO2 emissions. Also, AI, the use of AI or the adoption of AI lowers energy consumption and cost. Okay, furthermore, we could see here that the benefits also shows that AI allows for the access of wave energy. It benefits the environment. Just like climate smart technologies, AI is useful for climate change adaptation, teaching, research, and the implementation of sustainable development goals. However, according to CAC et al. 2020 and CAC et al. 2022, AI can also spore greenhouse gases due to the energy intensive process of machine learning. Okay, Lito Philho et al. 2022 also agreed that AI can spore emissions, especially through intensive activities. Ronick et al. Established that AI can help in enhancing smart grids, to improving disaster management and fostering and adaptive society. So what that is saying is that we've established that AI can be used as a mitigative tool. We are also establishing that AI can be used as an adaptive tool to climate change crisis. Cows et al. 2023 stated that AI can help improve and expand the present understanding of climate change, and it can contribute to effectively combating climate crisis. Okay, what is the bottleneck here, or the challenge, or the disbenefit? The potential of increasing the social and ethical challenges already associated with AI. So that part is trying to talk about ethical considerations, or the issues of ethics regarding the use of artificial intelligence in climate change research and across other fields also, and sporing greenhouse gases by training data and computation intensive AI systems. All right. Now, Carant et al. 2023 also established that AI can help to forecast the potential food safety hazards arising from climate change. And Nordgren 2023 stated that climate change mitigating and adapting roles, thus AI can be used for climate change mitigating and adapting roles. This benefit here, you could see here, or challenges or bottlenecks, are ethical concerns. Chen et al. 2023 says that AI could optimize power system efficiency, thus reducing electricity tariffs. This will also drive down environmental degradation or environmental pollution, or drive down CO2 emissions. Okay, and lastly here, we could see that Cortez 2023 also established, also affirmed, also asserted that AI can mitigate climate change. But the disbenefit here, or the bottleneck here, is negative impact on climate policy goals, especially through political processes. So what is the conclusion? Okay, first of all, the conclusion is that the benefits of using artificial intelligence is much more than the disbenefit. Okay, it means that climate change, using AI to tackle climate change crisis, has more benefit in stock than the disadvantages or the disadvantages. So here you can see the theories relating to technological innovation and climate change research include EKC hypothesis and the Porter hypothesis, which you have established. The AI tools utilized regarding climate change include machine learning and deep learning. We've established that. It was also observed that AI can either increase the greenhouse gases or inhibit it. The increase in greenhouse gases is caused by training data and computation intensive AI systems, okay, which means that energy-driven AI systems, all right? An increase in energy use can be a major boost, a major driver to environmental degradation, causing climate change problems. AI has climate change AI has climate change mitigating and adapting roles. It means that by the use of AI, we can use as a mitigating factor to climate change crisis, and we can also use to adapt to climate change crisis. In summary, the benefits of using AI to tackle climate crisis, it's more than the disbenefits. However, to make AI become more effective, AI regulations are very, very important. Then it's very important to state that AI does not stand on its own. AI is a subset of technological innovation. Okay, AI is a subset. It's part of the output or the fruit of technological innovation. Thank you very much.
Thank you very much, Dr. Somoya. Any questions for Dr. Somoya? Okay, seems like no questions. Since no questions, I would like to move to our next and last presentation. I'm going to share with you our last presentation provided by Dr. Rabhi Aicha. The paper titled Harmonizing Sustainability, Advancing Building Material Through the Integration of Thermal, Mechanical, Lighting, and Acoustic Properties in Plaster Polystyrene Biocomposites. I will present it. Just yes. Okay, I think we're having a problem with the voice in this video. So okay, I think we're having a technical problem with the voice in this video. So we have no more presentations for this session. This is going to be the end of our session. Thank you very much for your attendance, for your listening. I'd like to thank everyone. Thank you, everyone. And this is going to be the end of session 4. See you in session 5 after 15 minutes.
Hayat hızla akıyor ve biz bu hızı seviyoruz. Her güne heyecanla başlıyor, her anı doya doya yaşıyoruz. İlk günkü heyecanımızla yılları aşıyoruz. Zaman akarken biz de kendimizi arıyoruz. Heyecanla, merakla. Sen de kendini mi arıyorsun? O zaman zamana yetiş. Bu sadece kendini bulmakla ilgili değil. Asıl heyecan kendini yaratmakta. Bir şeyler mi yaratmak istiyorsun? Mükemmel. Metali işlemeyi, bir bina yapmayı, bir iş kurmayı, hatta bir şehir kurmayı öğren. Hayat kurtarmak, teknoloji geliştirmek, üretmek. Hepsi burada. Ve burada tüm deneyimler profesyonellerle yan yana. Ancak hızlı ilerlemeliyiz. Çünkü bugün şimdi gerçekleşiyor ve yarın çok yakın. Hayatta öne geçmek istiyorsan önce zamanın önüne geçeceksin. Hep ileri gideceksin. Bu Doktor Suat İrfan Günsel. Tanıyor musun? Onun da söylediği gibi. Üniversiteler toplumların dokuma tezgahıdır. Toplumları geliştirir, dönüştürür ve gelişmesini sağlar. O burayı bugünden yarına hazırlamak için kurdu. Senin için, ileriye gitmek için. Yana ya da geriye değil. Sadece ileri. Çünkü gelecek çok yakın. Hadi harekete geç. Fikirlerin ne kadar ileride olursa yarına o kadar yaklaşırsın. Yanındakileri de geleceğe taşırsın. Bu senin geleceğin, senin fırsatın şimdi. Hadi yarın yakın. Hepimizi ileriye götür.